So today we're going to be reviewing LT3, which is students will identify and describe the states of matter and identify changes in energy between the different states of matter. Now to help me out today, I have my co-host for today, and that is Evan Wittoon. So Evan, what I'd like you to do is I'd like you to answer these questions for me. State in which a substance completely fills its container. So what answer do you think that is?
I think that would be a gas.
And that is a good clue. That's gases will spread out and they will completely fill a container. How about the next one? A reaction that releases energy.
I think this would be exothermic.
And I think that's a good answer because when you think of releasing, you think of something exiting. So exothermic starts with EX just like exiting. So how about the most common state of matter in the universe?
Well, that would be plasma.
Now, even though we don't, and that's not the same plasma that's in your blood, it's a different, but even though we don't have a lot of plasma on Earth, it's the most common state of matter in the universe. Our sun, stars have plasma. How about state in which atoms are strongly attracted and do not change position?
Solid.
And it's a solid, and that's a good answer. That's why when we sit in these chairs that we're in right now, the chairs don't spread apart, we don't fall to the floor because they're solid. They're strongly attracted and they do not change positions. How about state in which matter flows as it takes the shape of a container?
I think that's liquid.
Yeah, and when you think of liquids, think of things flowing. You know, what flows? Well, water flows, rivers flow, and they're liquids. Now the last one, a reaction that absorbs energy.
The hardest one. Endothermic.
And when you think of absorbs, think of energy entering something. If you take an ice cube out of the freezer and put it on your counter, energy has to enter it in order to get the molecules moving faster. So the heat enters it, and endothermic starts with the same two letters as entering. So let's check your answers, and let's see if you're right. Oh, you got them all right. Great job. Now, my co-host is going to try this one too. So part of the learning target is understanding the different states of matter. So which one of these do you think is water to water vapor?
Water to water vapor would be evaporation.
Yeah, so when you have water and you boil it, it turns to steam. That's water vapor. How about solid to gas?
That would be sublimation.
Yep, and that happens with dry ice. It goes right from a solid to a gas. How about water vapor to rain?
Condensation.
Yep, and that's how we get our clouds. How about water to ice?
Water to ice would be freezing.
Ooh, and the last one, ice to water.
Melting.
Excellent job. Now let's hit check and we'll see if you have them all right. Ooh, you got them all right as well. I'd like to thank my co-host for helping out with the first part of this video, and I'm going to take over from here. So do you remember seeing this question right here? Do refrigerators remove heat from food or add cold to the food? Do you remember what we talked about? If you said it removes heat, you're exactly right. So I'm going to start it out. Do refrigerators remove heat? So I'm going to say refrigerators. So I'm going to say refrigerators remove heat from food. So I'm not going to say things like it will remove heat, because what is heat? What is it? You know, I'm grading this. You want to sell me your answer. And so don't say words like it, because then I'm trying to think about what do they mean by it. And sometimes we're not thinking the same thing, and that's why you get it marked wrong. So how about the next part of the question? Is food becoming cooler an endothermic or exothermic reaction? So think about it. If I put a bowl of something in the refrigerator and it's hot, what happens? Is heat coming in? No, 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 no. Heat is actually leaving it. And we get that from up above. Refrigerators remove heat. That heat is actually leaving whatever it is, whether it's a pie, whether it's soup, whether it's a turkey. It's leaving it. So is food becoming an endo or exothermic reaction? So what I like to say is the heat is exiting, right? So when you think of that, exiting, what are the first two letters? EX, here you go. Think of these first two letters. So is food becoming cooler, an endo or exothermic reaction? Well, so I'm going to say food becoming cooler. So I'm going to write it out. Is an exothermic reaction. Now, I'm not done yet because I have to answer this one. Let me move to a different color pen. So don't forget this one. Explain your answer. So food becoming cooler is an exothermic reaction because the heat is exiting the food. So you see what I did? I used this thing over here, this word that I used over there, and I actually put it in here to help me out. So if you can answer it, and again, use complete sentences, don't use words like it or because to start it out. I used it here, but that's because I answered it up above first. So use words to let me know exactly what you're thinking. So, and here is the last question that you're going to see on the test, or at least this part of the test. So let's look at it. You are on a deserted island with nothing but salt water to drink. Thankfully, you have the necessary equipment to desalinate the water. So desalinate means to get rid of the salt. So you're able to remove the salt from the water. So explain why you were able to boil the liquid from the saltwater solution without losing the solid too. Now, if this question looks familiar, it should be. One, you've had it since the beginning of the unit. Also, we've done 2 labs where you've gotten or you've desalinated the water. So you should be able to explain how to do this. We've seen this question before. Now, one thing I want you to look at, and I'm going to grab a highlighter here. I'm going to pull up a pen. Let me grab a highlighter. That's why you're seeing that right there. Let's choose a color. Now you notice underneath it says be sure to include something in your explanation about boiling points. So I want to make sure I add something about boiling points and the amount of energy required to evaporate a liquid versus the amount of energy required to evaporate a solid. So what I would do when you're taking a test is maybe even take a highlighter or take a pen and underline certain parts so you don't forget to do it. So I need to make sure I include these parts. Now what I'm going to do here, I'm not going to write it out. I'm actually going to type it out. So explain why you're able to boil a liquid from the salt water solution without losing a solid too. Be sure to include something about boiling points. So I'm going to add it out. I'm going to start to type this out. I can, so separate, oop, did you see it spelt wrong? So let me fix that quick. I can separate a liquid. How about this? I can separate the water from the salt because the liquid water has a lower boiling point than the solid salt. So what did I just do? I just answered this first part right here. Explain why you're able to boil the liquid from the salt water solution without losing the salt too. Be sure to include something in your explanation about boiling point. So I can separate the water from the salt because the liquid water has a lower boiling point than a solid salt. So that does a pretty good job of answering that. How about the second part? Talk about the amount of energy required to evaporate a liquid versus the amount of energy required to evaporate a solid. So now I might answer this. Or how about this? Boiling a liquid requires less energy than boiling a solid. So when I look at it, did I answer everything? Explain why you were able to boil the liquid from the salt water solution without losing the solid too. Well, I can separate the water from the solid because the liquid water has a lower boiling point than the solid salt. I'm going to add something to that. I might go on to say, so the liquid will evaporate before the solid salt does. So eventually the salt could evaporate, but it would have to go from that solid state into the liquid state, and then it would have to evaporate. So again, when you're answering this question, make sure you look things over, make sure you look at the whole answer, and not just say, oh, because it's a solid or because it's a liquid versus a solid. Make sure you answer everything that's in here. So I hope this review was helpful for you, and I hope you do well on the test. As always, if you have any other questions, please feel free to get in contact with me. You can come in before school, after school. I'll meet with you during lunch, or if it's a quick question, we have time in class, I'll take it there as well. Thanks. Bye.